Hello, and welcome back to another episode of Squaring the Circle. We're going to continue with our discussion of near Earth misses by asteroids that have occurred in the last, let's say, slightly more than 4 decades, about 4.5 decades, which encompasses the time since actually 3.5 decades, since I started watching and paying attention, observing and cataloging these near misses, which my first one, I believe, was 1989 that really caught my attention. And at that point, I began tracking the events of near flybys of asteroids and potentially pieces of comets. So that's what we've been talking about. And I think it's one of those things that when you start paying attention to it and realizing the the sheer numbers of these near misses and close flybys that have occurred, that it becomes an a an issue that we should be paying much more close attention to. But I'll let you make up your mind as we go through this. Like I said, this says here, close encounters while mankind sleeps. This is the second part. If you haven't seen the previous episode that has part one, then I would suggest you go ahead and watch that now. So we're going to back up a slide so we can pick up where we left off. We left off with the Halloween asteroid of 2015 that occurred on October 31st. And very appropriately, it has a very demonic expression or look to it. It almost looks like a skull, as you can see from this blurry photograph here. And as it says here, the asteroid 215 TB 145 was the biggest known object to pass so close to the Earth until another one of that size passes this close in 2027. And then I make a note down here and I say, of course, the key phrase is that there is no known object. Now, this is an important thing to keep in mind. Now, this is October 31st, right? It makes its clear close passage, which you can see down here was 302,000 miles. It's just a little bit outside the orbit of the moon. But here's the thing. Until October 10th, the space agency didn't know the 2015 TB 145 even existed. And at the time, more attention was on asteroid 2009 FD, which passed within about 4 million miles of Earth on October 29th, only 2 days before. Now, looking at asteroid 2015 TB 145, we see discovered October 10th. Its diameter estimated to be about 2,130 feet. Now, that's about 650 meters. Its distance at close passage, 302,000 miles, as I mentioned. It's about 2,800 times larger than the Tunguska cosmic object. That's, of course, just ballpark because you can see it's somewhat spherical. And this is assuming that the Tunguska object was somewhat spherical. But by using the formula for the volume of a sphere, we can, and idealizing these objects as spherical, we're not going to get exact numbers, obviously, but we're going to certainly get in the ballpark. All right. So this is about 2,800 times larger than the Tunguska cosmic object. And if we scale up by energy release, then it would be about 2,800 times more energetic when it hit the Earth. And this would be large enough to definitely penetrate the atmosphere and strike the Earth itself, either on land or in the ocean. What we find out is that by just scaling and using Tunguska, and this is one reason I got into the Tunguska explanation in depth, was because I like to use Tunguska object sort of as a yardstick, right? We have an actual area that empirical data that we can use to determine the energy release, the size of the object, and how much damage it did. And putting all of that together, we come up with the rough ballpark energy released of about 1,500,000 megatons of TNT. That is 15 megatons, and a megaton being a million tons of TNT, right? So I like to use that as a yardstick because another reason, and I pointed this out, I think, in one of the previous podcast episodes, that when you look at the square mile area of total devastation caused by the Tunguska explosion up in the atmosphere, it's about 820 square miles roughly. Now, if you take any urban area in the U.S., in the world, for example, Atlanta, near where we live, is a pretty sprawling urban area, and it's inside a perimeter highway around, it's called 285. The area inside 285 is roughly the same area as the area of destruction caused by the Tunguska cosmic object. You can apply that to almost any major city in the United States and get similar results. If you look at the perimeter interstate around Washington, D.C., you'll see it's roughly the same scale. So the Tunguska object, you can think of that as a city killer, a city buster. It's big enough that it's not going to cause regional destruction, we're saying the size of a state, but it's going to cause destruction that could wipe out pretty much almost any city on Earth, okay? Or at least wipe out the core of the city and a lot of the outlying area. Again, about 820, 825 square miles. It's just about, I think, 2,100 square kilometers, if you think in terms of kilometers. So it makes a very useful yardstick for us to talk about impact events and their power, their energy released, and so on. So this one was about 2,800 times larger in volume than the Tunguska, and there is an element of conservatism in our speculations here because most of these asteroids are going to be several times denser at least than the Tunguska object. Well, that greater density, that greater mass and density of that object striking the Earth or the Earth's atmosphere carries a much greater kinetic punch, okay? So really, I think our estimates are scaling upward of energies released, and impact is actually on the conservative side. So if we said 2,800 times larger than the Tunguska cosmic object, and we assume that the Tunguska cosmic object is 15 megatons, this makes this an impact of this particular asteroid onto the Earth about 40,000 megatons, which is, you know, an order of magnitude beyond the entire nuclear arsenal of the nuclear nations. Okay, so it would be a bad day if this thing were to strike the Earth, and this would be, of course, large enough that it would penetrate the atmosphere. Unlike the smaller examples we've seen, like Chelyabinsk and Tunguska, they were not able to penetrate the full depth of the atmosphere. And that was functionally two things. It was the density of the object and the size of the object. The velocity of the object is also going to play a role, but it's going to be primarily the size of the object and the density of the object. It determines whether or not it can fully penetrate the atmosphere and reach the surface of the ground. Okay, so now let's continue on. And on April 19th, 2017, a nearly 3-mile wide asteroid makes and it says relatively close call with the Earth. And relative is the key idea here. Now, this was asteroid 3122 or 3122 Florence, discovered in March of 1981, and the date of the closest approach to Earth was September 1st in 2017. It was within 4.4 million miles. So that's, you know, that's plenty ways away. That's, you know, that's about 16 times the distance to the moon. So, you know, obviously nothing to worry about. However, the thing that should cause us to pay attention to this is the size of it. It's 3 miles wide. So that makes it about 1,175,600 times larger than the Tunguska object. What would that mean in terms of an impact? Well, that would be just extraordinarily damaging and destructive. A 3-mile wide asteroid impact on the Earth, we could call that a civilization killer. And it would probably also cause a fairly widespread mass extinction, certainly within the region of major devastation. Species would survive, for example, on the other side of the planet, but A 3 mile wide asteroid striking the Earth. Now you're looking at a whole host of secondary consequences and feedbacks. You're looking at widespread fires. You're looking at fallback breccia that's going to be igniting fires over a very large area. You're going to be looking at an enormous amount of soot and dust being injected into the atmosphere. So it would be a bad day on planet Earth for all concerned. Luckily, it was 4.4 million miles away. Okay. I'm going to come back to this idea of, relative distances within the cosmic environment and what that may imply in terms of thinking about consequences of hypervelocity impacts. Okay. We're taking a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I had remembered to do that. So that night I put some of the salve on, went to bed. Though being in the construction and building industry, I've had many falls and injuries and stuff, and I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week, I was getting around pretty good. I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. So now, April 19th, 2007, we go from okay, so this is part of the same. This is another asteroid, 2004 JO 25th, discovered May 5th on 2014, and its closest date of approach was April 19th, within 1.1 million miles. And it was a rotating, tumbling asteroid. Let me see, did I get the dates mixed up here a little bit? No. So this was the date of the article, apparently. This was the date of closest approach. So this was September 1st. Okay, so actually this one should have come next. But so then on May 5th, astronomers discovered 2014 JO25, and it made its closest approach to Earth on April 19th, 2017, within 1.1 million miles, which is, about between 4 and 5 times the distance of the moon. And here's the object rolling and tumbling in space. Okay, October 12th, 2017. Buzzworthy space rocks, asteroid hunters prep for near miss. So this is 2012 TC4, discovered on October 4th, 2012. And as I talked about last in part one of this, the discovery year is always the first part of the name given to the asteroid. So its diameter was 45 to 50 feet. Closest approach to Earth was 31,000 miles, which is really close. That's like within the range of geosynchronous satellites. Slightly smaller than Chelyabinsk. Now, we've talked about Chelyabinsk. There were about 7,000 buildings damaged. There was 1,500 injuries. To my knowledge, no one was killed. This was being slightly smaller. It could have certainly caused damage. And depending. Now, there's another factors. When you're getting here, you're right in that threshold of where you get from incredible aerial burst with accompanying light show and all of that, or you are getting into surface damage. Now, with Chelyabinsk, which was estimated to be about 60 feet in diameter, we got surface damage. At 30 feet in diameter, there'd probably be some spectacular effects. There'd probably be a boom and a shock wave, but surface damage would be minimal. But once we've doubled that size, get up to about 60 feet in diameter, we know from Chelyabinsk now that is enough to cause surface damage, and under some circumstances could probably cause fatalities. Just depending, the angle of approach has an effect too, because if it's a low, you can picture this, if you've got a low angle of approach, what that means is that it's having to pass through more atmosphere. So as it passes through more atmosphere, that's more friction, that's more compression that forms in front of the moving object, Whereas if it comes in at a very steep angle, you can see it's going through much less atmosphere. And so it's going to have a greater chance of penetrating the atmosphere and reaching the surface of the ground. Okay, this something that's a diameter 50 feet will not reach the surface of the ground, but it's going to create one heck of an explosion. That's for sure. And sonic booms. All right, so this is October 12th, 2017. Now, come forward. Now, I'm skipping. Bear in mind that I'm certainly not cataloging every near miss that has occurred every year or every month. I'm skipping over a lot of them. I just don't have time to count every one of them. I'm trying to make a point here, and that is that once you start paying attention to the larger environment, you're going to see that, yeah, it's much more active than anybody had imagined even a few decades ago. So on July 25th, 2019, astronomers missed the asteroid until it was nearly on top of them, but the space rock has already passed harmlessly by. A large asteroid just zipped between Earth and the moon. Now, this one is pretty significant. Okay, 2019 OK is a near-Earth asteroid noted for its sudden surprise discovery on the day before its close flyby, June 29th. Okay. Let's go just look at some of these with me here on this as I'm talking about it. Asteroid 2019 OK was discovered on July 24th, 2019. Notice your diameter 330 feet. So you can do the calculations, and you'll see that it's 10 to 11 times larger than the Tunguska cosmic object. Now let's assume that it's 10 times more energetic upon impact. And again, this is going to be conservative, right? So if we go 10 times and it's 15 megatons, then obviously we're at 150 megatons. So given that typical large nuclear weapons, hydrogen bombs that were deployed during the peak of the Cold War were about a megaton, you can see that this would be equivalent to about 150 hydrogen bombs if each bomb was 1 megaton each. So you can see this would be regionally devastating. Let's assume area. If we go 800 square miles for Tunguska, and then it's 10 times bigger, that means it's 8,000 square miles of damage and devastation. Now, this thing, see, this would be a global event of no trivial significance. An event like this, caused by an impact of an object this size, could have major disruptions. I mean, because for one thing, it's going to affect the climate. Just like when we talked about Tunguska, one of the things I hope you learned from that is that there were enough climatic effects to show that even a hypervelocity impact of that local distribution still had a global climatic signal and environmental signal, right? Now, if we go 10 times that, yeah, it's going to be a very significant global signal. Now, how would that signal manifest? Well, one, it could affect climate changes that could take a couple of years, 3-4 years to play out. And in that time, it could be that there is obstructions in the atmosphere that could cause cooling. There would be possibly all kinds of secondary consequences that could certainly disturb the equilibrium of global society for at least a few years. Now, would that manifest? I don't know, but it's certainly something that needs to be talked about, because passing 44,000 miles, that's pretty close. Let's go assume 250,000 miles for the average distance to the moon. Then you're looking at here, yes, this is 5 times greater. It's like 1/5 the distance to the moon, a little bit more than that. Okay, let's see what we got next here. July 25th. So this was the same. This was just a commentary on that asteroid surprise close approach illustrates the need for more eyes on the sky. Yes, it certainly does. That was one of the implications of it. And a lot of astronomers noted, well, look, we've got this thing. It was big enough to have caused major damage. If this had If this had come in and hit the Earth over an urban area, well, you'd have had a few million people instantly killed and a few more million at least injured and maimed. So this wouldn't be a little event. I mean, this would be on the scale of the greatest disasters that we could have recorded in history. Okay. So that's why we see asteroid surprise close approach. Close approach illustrates the need for more eyes on the sky. So now we've got August 15th, 2019, coming forward from July. We've got just a month later, NASA asteroid tracker, 328-foot near-Earth object to zip by Earth, past Earth on Friday. Now, this is asteroid 2019 PJ, discovered August 5th, 2019, diameter about 328 feet. And you can see down there, I've done the calculation, it's about 84 times larger than the Tunguska cosmic object, and 84 times 15 megatons suggests a megaton explosion in the range of about 1,260. Now, of course, this is only ballpark. You might be talking about something from 1,000 megatons to 1,500 megatons. But this certainly, the idea is to just give you a ballpark idea. Now, given that this is 84 times larger than the TCO, the Tunguska cosmic object, again, if we go 800 square miles damaged by Tunguska, and then this is 84 times bigger, right? It's not necessarily going to be a straight linear extrapolation upwards. There's going to be many other factors involved. One, for example, just the terrain, the lay of the land. How does this thing explode in the atmosphere, or does it reach the ground? And that's going to depend, again, on velocity. It's going to depend on angle of approach. It's going to depend on density. We know the size here, but here's the point. It would be extremely damaging, and it would be many times more damaging than the Tunguska object. Now, can we just make a straightforward linear extrapolation and go 84 times 15 megatons? May get us in the ballpark, but once again, this is an event. This is an impact that would be roughly totally destructive over an area of a mid-sized U.S. state. Okay, so asteroid watch, 4 near-Earth objects to pass by in June. Do you remember? This was just last year. I mean, in 2020, June of 2020. What am I talking about? Several large objects will be passing Earth in June. And just in case 2020 was bad enough already, on June 6th, 2020, asteroid near-Earth object 2020 LA will be whizzing past the Earth. Let's look at this one. This was a member of the Aten group asteroid. Now, what is that? Well, an Aten group asteroid, look down here at the bottom, you're going to see here that they're asteroids that have orbits that bring them into proximity with the Earth. In other words, they're Earth-crossing asteroids, okay? Aten group, they're different than the Apollo, and the main thing that defines them is the fact that they are Earth-crossing asteroids. Now, this thing has a diameter of 2,300 feet, so it's around 3,500 times larger than the Tunguska. Near miss on June 6th, about a distance of 3.6 million miles. Okay. Now, again, that's plenty of distance between us and this object. But again, 2,300 feet in diameter, that's, getting up in the vicinity of being half a mile. This would cause global consequences that would be severe. I'm going to pause for just a minute to talk about our partners over at Shippo, who may save you a significant amount of headache in your day-to-day business. We sell a variety of geometry tools and models, like our beautiful platonic solids here at Randall Carlson LLC. And when it comes to managing shipping, e-commerce, and returns, we've been using Shippo for over 4 years now, and we're very pleased with their service. Shippo's interface is intuitive, the primary order page is easy to navigate, and we have enjoyed stellar technical support. If Shippo can help you with your needs, please use the code below to partner with a great company while supporting our work here at Squaring the Circle. Thanks, and now back to the show. Maybe not the termination of civilization, but it all depends on the secondary consequences. If there was enough, let's say it lands in the ocean, well, it's going to create gigantic tsunamis that are going to wash the coastal areas on all sides of whatever ocean it falls in. If it falls in the Atlantic, well, that's pretty much goodbye East Coast of the United States. How many fatalities would there be in a case like that? Hard to say, but it wouldn't be exaggerated to think that it could be in the hundreds of thousands, if not millions. Okay. If it hit on land, well, there's going to be a whole series of secondary consequences, including dust injection, fires, and injection of soot. And all of this can cool the environment. And we know from I think we talked about in one of the early episodes of Squaring the Circle, the consequences of the eruption of Tambora in 1815, which led to the year without a summer in 1816. Now, if we were to, let's say, by a factor of 10 or one order of magnitude, to increase the environmental consequences to encompass the effects of an impact of a half-mile diameter object or a half-kilometer object, well, we're looking at greater consequences than the Tambora eruption. So what does that mean? Well, it could mean that, yeah, you've got probably a million or a few million people killed either in the tsunamis or in the immediate effects of the blast. But then you're going to have a couple of years where you're going to have a cosmic winter and you're going to have widespread agricultural failures, likely on a global scale. And this is going to be followed by famine. This is a very realistic possibility that you would then have famine in the wake of an event like this. And that famine leading to malnutrition would then also lead to um, the compromising of one's immune systems, which then creates the conditions for pestilence and diseases. So you can see there could be a whole series of cascading effects as a result of an impact like this. This needs to be considered and talked about because we aren't talking about any of this. It's just not this seems to be on anybody's radar screen except for a small group, primarily of scientists, astronomers, who are witnessing and testifying to the extent to which our near-Earth cosmic environment is inhabited by potential impactors. So let's keep moving here. April 15th, 2020, near-Earth asteroid 2020, GH2, very close encounter. Here's an image of the thing taken to 12th of April on 2020. Asteroid 2020 GH2, discovered in 2020, as you already know now, approximately 100 feet in diameter. Now, that puts it midway, yeah, like down here it says roughly between Chelyabinsk and Tunguska in size, large enough to cause considerable damage at the surface. So this is the key. If it came in over an urban area, it would undoubtedly cause some number of fatalities. Remember, Chelyabinsk did not cause fatalities that we know of, at least that I don't know of, unless there was some prolonged in the aftermath. But it didn't lead to any immediate fatalities caused by the explosion itself. However, if we go up from 60 feet to 100 feet, yeah, now we're within that realm where we could definitely be causing casualties, maybe hundreds, if not a few thousand. It all just depends. Is it going to be over a sparsely populated rural area, or is it going to be over a village? Now, is it going to be over a city? Here's the thing. If you're over a village where you've got, or a city where you've got a lot of buildings, let's say built out of stone or built out of concrete, and they haven't been properly engineered, for example, like made earthquake resistant, well, an aerial blast such as Tunguska or Chelyabinsk could certainly damage these buildings. Now, we know from earthquakes that a lot of the fatalities, they're not caused actually by the earthquake itself, they're caused by the collapse of buildings and people being trapped under the rubble and being destroyed in the collapse of the buildings. The same thing would apply to an impact event. Okay. So here, 100 feet, now 223,000, that's right at about the mean distance of the moon, or yeah, maybe closer to perigee, but it is just within the orbit of the moon. But moving it, look at this velocity. 62,500 miles per hour, which is 17.36 miles per second. This thing is moving. You understand that velocity, what that does to the kinetic energy that is released upon impact? That's extraordinary. Think about that. 1001. In that passage of time, it's moved almost 18 miles through space. This is really fast. Okay. So let's see. Then we'll go up to April 24th, and we see that NASA's tracking a giant 750-foot asteroid traveling at 62,000 miles per hour near Earth's orbit. And a huge space rock known as 2020 HW3 and measuring as much as 750 feet wide. Now that's big, right? 750 feet. Remember, Tunguska was about 150 feet, right? So it was discovered in 2020, diameter 750 feet, velocity 62,000. So it's in the same ballpark as what we just saw. Close passage on April 24th, 2020, safe distance of 4.8 million miles. So again, we're not seeing anything that's going to immediately threaten us or did threaten us. So let's go to the next one. April 29th, 2020, radar views show big asteroid 1998 OR2 tumbling in space ahead of Earth flyby. Asteroid 1998 OR2 discovered on July 24th, 1998. Look at its diameter, greater than a mile, possibly around 6,500 feet in diameter. Now, it's also moving. This seems to be a very typical speed at which these things are moving. Closest distance, 4 million miles, and its closest passage was on April 29th, 2020. It was about 80,000 times larger in terms of parking the volume of the thing than the Tunguska cosmic object. So at 80,000 times larger, can you imagine the consequences? This would be a civilization killer, absolutely, no question. It would probably be a mass extinction event as well, at least over vast swaths of the Earth's surface. Yeah, this is something that would take us decades or centuries, probably centuries, to recover from, if we were able to even recover from it. Because of just, it really boils down to, like I was talking about before, the secondary consequences, the feedbacks, and so on. All right, so then on August 16th, 2020, we have a small asteroid, only 20 feet, but it came within 1,800 miles of the surface of the Earth. Now, it's more likely that the really close ones are going to be small, and the really big ones are going to be farther away. Because for one thing, the smaller the object, more abundant they are, right? But what we have to really take into account here is where this threshold is, the threshold between surface damage and just a spectacular light show in the upper atmosphere when the Earth encounters these things. Now, 20 feet, no surface damage. Magnificent, explosive, mind-blowing light show, yes. Audio effects, yes. Sonic booms effects, yes. And at 1,830 miles, that's really close to the surface of the Earth. This happened on August 16th. Like it says here, it's too small to cause surface damage. So this is about 1/3 the diameter of the Chelyabinsk. All right, September 24th, 2020, a newly discovered asteroid will pass close to Earth on Thursday. This 20 to 30 feet, so again, too small, but within 13,000 miles of the Earth. That's very, very close as well. Now, again, this would not cause surface damage. It could. Here's the thing. It depends a lot on the density. If it fragments in the atmosphere, it's very possible that it could create a meteor shower that strikes the surface of the Earth. This is certainly a possibility because we know this happens. If it's a lower density object, well, yeah, it's probably going to blow up like Tunguska did or Chelyabinsk. This is an asteroid, so it's going to be denser. Think of it this way. Think of Tunguska as a piece of ice. Think of an asteroid, a carbonaceous chondritic asteroid or a stony asteroid, about three and a half times denser. The kind, if you pick up in your two hands, you got an ice cube in one hand, a piece of ice, and a rock, like you would find typical sedimentary rock or something sitting next to a creek or river. Then when you get to the dense end of the continuum of cosmic objects, you're looking at something that's more like cast iron. And there's everything in between in terms of density. So density is going to play a big part on exactly and precisely what kind of surface consequences ensue upon encountering. Okay, so then let's come back up to November 14th, and we have this asteroid just skimmed Earth's atmosphere. 2020 SW was discovered November 14th. Look at this, date of close passage, November 13th. So it was actually not discovered until the day after it passed us. Now, again, this is a smaller object, 30 to 36 feet, so it's not something that's going to lead to fatalities or injuries or major significant surface destruction, unless now you had pieces of this, if this thing struck the ground, which if it's an asteroid, that's possible. And that could, depending on, where it struck, how densely the area was populated and so on, it's not out of the question that there could be fatalities. The distance during close passage was about 238 miles above the Earth's surface. So this is really, really close. Okay. So this year, 2020, was interesting. Record number of asteroids seen whizzing past the Earth in 2020. Despite the pandemic disruption, astronomers detected thousands of previously unknown near-Earth asteroids last year. And then we have, coming up in following June of 2022, a blue whale-sized asteroid to screech past Earth in close encounter on June 6th. The asteroid is predicted to miss Earth by more than 2 million miles. So again, it's at a safe distance. But you see, here's I think the way we have to put that into kind of a perspective. Let's think about, most of our ancestors through a lot of Earth history lived in environments that kept them much closer to nature and much closer to the natural processes and systems, ecological dynamics that involve predator-prey relationships. Now, if you are finding yourself, in a typical urban environment, as you would today, it's probably not likely that you're going to get stalked by a predator, such as a lion or a tiger or a bear or whatever, although it does happen, yes. Okay, now if you're living in an urban environment, the predators you may have to be more concerned with might be of the human variety. But, it's always a good idea, no matter whether you're in nature or in an urban environment, to take stock of your environment and to see what the potential threats might be. And if you're out in the wilderness, there are going to be real threats that you have to take into account. We are, of course, much more immune today from the kinds of threats that our ancestors would have been subjected to. But imagine if you're set down now, maybe with only primitive weapons in the sub-Saharan Africa. Let's say you're set down in the Serengeti Plain. Well, you're definitely going to have to deal with some predators, right? And the first thing you would do, if you have a survivor mentality, is you're going to take stock of your environment. And if you're climb a tree in order to get the larger view, and you look off in the distance on a ridge and you see a pride of lions, well, you're going to not necessarily freak out because you're about to get attacked, but you're going to take note of that, and you are going to consider the fact that there are, in fact, lions in your environment. And so you'd better take be cautious, right? If you were set back down into the terminal ice age, you might look take stock of your environment and realize that, if you're in North America, you might be dealing with the great North American cheetah that used to live here, or the North American Pleistocene lion that was the size of a horse, or a pack of dire wolves, or um, you know, what else? Saber-toothed cats, the Arctodus, the giant short-faced bear. There was a lot of things that might potentially eat you. So the first thing you're going to do is you're going to take stock of your environment, and hopefully you're going to assess the potential threats, not when they're on you about to devour you, but long before that, because you then maybe have some time to take whatever precautionary measures you need in order to minimize the chances of you getting eaten. Well, here's the thing. We're here now realizing that, we talked about the discovery of Ceres, the first asteroid in 1801. And that was the first one. Okay, so now we had a catalog of asteroids that included one asteroid. Well, within a few decades, it had grown to 4 asteroids. Well, as we come along, what we're discovering now is every day we're discovering new asteroids. Every week or month, we're realizing that there are asteroids flying through near Earth space. Now, up to this point, luckily, they have been relatively far away, at least the big ones that could cause global or widespread regional damage. However, what we're seeing, though, is this, that the cosmic environment in which our planet exists, in which we exist, is a much denser population of potential predators than anyone had imagined 50 years ago, right? Now, is this something that we can consider can continue to blithely ignore with the idea that this is so far removed from us and it's so woo and so out there and so science fiction-y that it bears no direct ramifications for our own situation down here on the surface of this planet? I think that would be a fatal mistake to make that assumption. Let's just go a little further with this. The next one comes from March 25th of last year. A 200-foot asteroid, 2023 DZ2, passed closer than the moon. So it was up to 87 meters, actually, in diameter, which was 285 feet. Now, probable kind of a mean in between those two is about 210 feet. In any case, it's quite a bit larger than the Tunguska cosmic object. In fact, about 8 times greater in volume, maybe up to 10 times greater in volume, depending on what the actual diameter of the object is. Discovered in late February 2023, and then less than a month later, it zooms by the Earth closer than the moon. Now, if this thing had struck the Earth, yes, it would be very destructive. And using a straight line extrapolation from Tunguska, we could go times 8, and that would be the equivalent of about 120 megaton explosion. Now, that's enough to wipe out pretty much a mid-sized U.S. state. It would also have clearly discernible global consequences. And again, there's so many variables that we don't know exactly what the feedbacks would be, exactly what those secondary or tertiary consequences would be. But clearly, at this scale, when you're talking 8 or 10 times greater impact energy than Tunguska, we're looking at clearly discernible global effects. Okay. Then we jump forward a few months, and June 25th, there was a house-sized asteroid, MU2, fly by the Earth at 2,000 miles per hour. Again, it was small enough that it wouldn't cause surface damage, but if it did enter the Earth's atmosphere, it would create one hell of a light show. July 15th. Now, this one, I realized that the global astronomical community has come up with a new yardstick for measuring the size of asteroids. I'm not sure if these are chickens all gathered in a bunch or if they're lined up, no beak to tail. They weren't clear on that. but it's at about 25. I guess we could calculate this out at 25 meters, which is what, close to 80 feet. That's the size of over 35 chickens. Okay, so diameter 60 to 90 feet, roughly the size of Chelyabinsk meteor or somewhat larger. So we can then extrapolate from that and realize that if a town or village, let's say a town the size of Chelyabinsk, was attacked by 35 chickens, is that what this means? That there could be serious damage, 1,500 injuries, and maybe perhaps 7,000 buildings. I guess it depends on the size of these chickens. Now, are these ordinary chickens or are these mega chickens? Now, were these late Pleistocene chickens that were maybe 300 to 400 pounds each? I just don't know. They don't specify that, but I think we do need clarification on that matter. So anyways, what's the consequence of all this? What are the implications of all this? Well, perhaps it's time to start praying. Potentially hazardous asteroid to pass Earth on Sunday. Now, this is July 16th, 2023, diameter 910 feet. This is 2023 MG6, a stadium-sized asteroid. Now, that is getting up there. 2023 MG6 has a diameter of approximately 271 meters, about the size of a stadium, and will swing by our neck of the woods at 23:37 South African time. It will also zip past as if it's late for work, moving at a relative velocity of 12.38 kilometers per second and a hyperbolic excess speed of 12.37 kilometers per second. In other words, the asteroid will be speeding past us at 44,564 kilometers per hour at a distance of 3.6 million kilometers. Now, 3.6 million is about kilometers is about 2.2 million miles. So it's, again, at a safe distance. But here again, I want to emphasize what we're seeing and realizing is that these objects are out there. They're all sizes. They're zipping by us all the time. Now the question is this: have they been zipping by the Earth all along, but 100 years ago, 200 years ago, we just weren't seeing them? And now, of course, we have the technology to discover them and count them and catalog them. So in other words, has the distribution of these near misses through time been more or less uniform? We just weren't able to see what was going on? Or are these near misses increasing in frequency? I think that's a really important question, and we don't know the answer to that. But in any case, I think what we are seeing clearly should be causing us to stop for a minute, take a time out, and consider, because the one hand, maybe the potential of being impacted in the next few decades or so is remote enough that it's not a factor of concern at the present. But it also could be that it's a much bigger concern than we realize. And for one reason, even if the consequences, I mean, even if the probability of something happening of a cosmic impact, let's say on a yearly scale compared to a hurricane or an earthquake or a wildfire, is much lower, the consequences of an encounter, say with an object a few hundred feet to a few thousand feet in diameter, is many times greater than a hurricane or an earthquake or a volcanic eruption, potentially. This is why we really need to be paying attention. And we aren't. We just aren't paying attention. Astronomers are seeing this, and they're going, well, it sure does look to us like we're a lot more vulnerable than we had imagined a generation or two ago. And they're absolutely correct. That we maybe not in actuality more vulnerable. We're just realizing that we're more vulnerable. Okay, let's look at a few more here. July of 2023, just a little over a year ago, there was another near-miss asteroid and the urgency of asteroid deflection. Can we stop them in time? That is a question that's finally starting to be raised in mainstream media. Somehow it doesn't seem to be filtering up, though, to our leaders who should be looking at stuff like this, right? Because they're too preoccupied with all their other political games and agendas that they're trying to push in their own particular, power games that in control and domination of global resources, that they're just not paying attention to that wild card, that black swan event that could come in and completely disrupt and change the rules of the game for all concerned. And then here, good question. What astronomers learned from a near-Earth asteroid they never saw coming. No one spotted Space Rock 2023 NT1 until 2 days after it missed us. It was only 1/4 distance to the moon. It was about almost 200 feet in diameter, 2 1/3 times larger than the Tunguska cosmic object. Okay, this thing, only 1/4 the distance to the moon with a slightly different trajectory. That could have been a direct impact. If that had been East Coast of the United States or Europe, West Coast of the United States, we could be looking at several million casualties. It would completely overwhelm, for a short period of time, overwhelm our healthcare and our trauma centers dealing with something like that. It would also create enormous supply chain disruptions because, for one thing, try to imagine the destruction of a major hurricane, right? And one reason that recovery from a hurricane event can be facilitated and accelerated is because you have this surrounding infrastructure. You have a large ratio of intact infrastructure to damaged infrastructure. So that's an important point to keep in mind. Anyways, if we have a large impact, you're going to have a much different ratio between intact infrastructure and damaged infrastructure. There is a point, there's a threshold, and we're going to talk about these ideas in upcoming episodes of Square in a Circle. There is sort of a threshold, our boundary conditions, where if you cross those boundaries, they are in effect tipping points, to use that term, that overused term, tipping points, where the ratio of damaged area to infrastructure, intact infrastructure, is so great that it is a very large challenge for the intact areas to respond to the extent of the devastation. I mean, because we could be looking, in effect, similar to World War II, right? Where it took, a decade or more for many of these economies, particularly of Europe, to recover from the damages caused by World War II. And then June 29th, 2024, we're coming up very close to our own time. A newly discovered asteroid larger than the Great Pyramid of Giza will zoom between Earth and the moon on Saturday. This is 2024 MK4. As it says, it poses no particular risk to Earth, but again, it's just another, all right, heads up, people. These things are going on over your head, heads up. Look up to the sky once in a while and realize what's going on up there. It's not just an empty zone of complete inactivity. So these are two large asteroids this summer that came by, and this interestingly came by right after the Cosmic Summit, in which I talked about the potential of there being new near misses. I actually told everyone in the audience to pay attention. I don't know how many of them did, but I did actually tell them in the audience, pay attention, because we're going to have some more near misses in the near future, probably within the next month. And right almost as on cue, we had two large asteroid close approaches. Asteroid 2011 UL21. It had a 1 mile diameter. So again, that's a civilization killer. It also has a moonlet orbiting at a distance of 1.9 miles. Now that moonlet could be something on the size of Tunguska. Now the other one, asteroid 2024 MK, was within 184,000 miles. So it was a lot closer than 2011 UL21, but with a diameter of about 500 feet, that would be about 37 times larger than the Tunguska object. So There you're looking at an area of total devastation that again would be on the scale of, a mid-sized American state or a small European country. So the question raised, how many potentially dangerous asteroids nearly miss the Earth each year? Well, the answer is last year, Earth had more than 100 close encounters with large asteroids. What are the odds of a direct hit in the near future? And I make this comment. The more we learn about our cosmic environment, the more we must reconsider and reevaluate the probabilities of a hypervelocity impact event, potentially with regional and global consequences. So this, I think, is just, it's time. And I think, I'm afraid what it's going to take is another Tunguska type event to get people, to shock people out of their somnambulance and realize, hey, we are, whether we like it or not, part of a much larger cosmic environment. And that cosmic environment has a very powerful role to play on everything that happens down here below on the surface of this planet. So, in conclusion, I think we'll say this. What astronomers now find alarming is that the asteroid MN4, now appropriately dubbed Apophis, will be passing so close to the Earth. Now, this is in 2029. Will be passing so close to Earth that our gravitational pull may affect the asteroid's orbital path, making its return flyby in 2036 unpredictable. Much like the proposed and bureaucratically stalled Indian Ocean tsunami early warning system that would have saved untold thousands of lives, astronomers in the near-Earth object research face the same lack of pre-disaster support despite growing and ample evidence. One reason is that the authorities have a tough enough time balancing budgets without extending taxpayer funds to hunt for long odds objects in space, no matter how short those odds seem to get. Does it get much shorter than 5 minutes? Now, what is this referring to? Well, this. This is not even enough time for a shower. The difference between life and death for millions on July 13th, 2029. The closing velocity of an incoming asteroid is about 12.6 kilometers per second. And if it were to cross the Earth's orbit, a near miss distance in thousands of kilometers would translate into a mere few minutes from impact. Okay, this is something to keep in mind. The 2004 MN4 could have caused a catastrophe that would make the Asian tsunami seem like a walk in the park. This isn't pie in the sky doomsday type speculation, but documented scientific fact. As tracking proceeded, the figures have fluctuated slightly, but the closest astronomers predicted the asteroid 2004 MN4 would miss our planet is by a mere 3,380 kilometers, or 0.53 Earth radii. So just over half the Earth's radius. Worst case, inner edge of the predicted eclipse. Or in more frightening terms, under 5 minutes away. Now, this is coming up. This is in our future. Now, it's not going to, Apophis is not going to strike in 2029 on July 13th, but it's going to come very, very close to the Earth. That close passage is going to deflect it in its orbit. That deflection could possibly be in the direction of becoming even closer to Earth on the next time around, which will be in 2036. Now, what does that mean? Well, we're going to pick up this conversation in the next episode. So we're not going to get into that right now because we've sort of gone beyond our limits for this episode. But we're going to continue this conversation. We're going to be looking at the implications of this. And then what we're going to do is we're going to start looking at the evidence that could confirm whether or not recent planetary history, which encompasses the history of civilization on Earth, whether there is evidence that there have been impacts with some frequency, relative frequency, that would be of major implications for the historical narrative, whether or not impacts such as that have actually occurred, let's say, within the Holocene, the last 11,600 years. So that's what we're going to look at next. We're going to ask this question. Okay, we know that there have been major earthquakes in Earth history that have affected the course of life on Earth. Did I say earthquakes? I meant impacts, hypervelocity impacts in Earth's history that have affected the course of life on Earth, that have caused mass extinctions, rapid speciations, which in itself is worthy of more investigation, particularly to understand what triggers the rapid recovery, rapid speciation events in the aftermath of a global catastrophe. Then we're going to go from the big view, we're going to hone in on the Holocene, and we're going to ask this question: is there evidence that past civilizations have been dramatically affected, if not even destroyed altogether, by cosmic impacts? And that's where we're going to be going in this discussion. So I hope you hang in there, join us for this, learn about this, to me, very important issue that is not getting the kind of attention that it warrants. And we're going to try to remedy that through the Squaring of the Circle podcast. So I look forward to seeing you in the next episode. And by the way, we're going to have a number of interesting interviews. We're going to have interviews coming up with interesting people that are doing cutting edge work that we think is going to contribute to creating a better civilization, a more peaceful civilization on the earth. And the last thing I will say here is that we saw the comment from a few slides ago that the question was about the lack of funds for the what was referred to as the bureaucratically stalled Indian Ocean tsunami, which would have saved hundreds of thousands of lives potentially, right? Well, we're sort of in that same conundrum right now. And so we continue to spend billions, hundreds of billions of dollars on preparing for warfare with each other, when it may turn out that cosmic predators are breathing down our necks, and we really need to be getting our act together as a species on this planet and figuring out how we're going to preserve not only the civilization that we've built upon this planet, but also provide some kind of long-term environmental stability. And that's where we're going to leave it for this episode. And I look forward to seeing you in the next episode of Squaring the Circle. Thank you for joining me.